You let me know when. Okay, welcome everyone to our series on origin. And we are so thrilled that you are here with us tonight. And for those of you who may still be en route, you're welcome too to join us in progress. If you have cell phones, we ask that you would please turn those off. And for those of you who may be visiting, the restrooms are just right outside the door and to the right. We also invite you to bring a friend. This is going to be a very informative seminar, and please bring a friend. And I will be the seminar speaker. My name is Pastor Tim Jones, for those of you who don't know me, and I'm thrilled to be able to join with you in this study. So before we get going, please join me in a word of prayer. Loving Father in heaven, we thank you for being our God. We ask that you would bless us this evening as we come together to study this very, very important subject. We ask all of these things in Christ's name. Amen.
Where did everything on planet Earth come from? How did life start? How did humankind begin their journey on planet Earth? Hi, I'm Dr. Stan Hudson. I want to welcome you to this 6-part series on the subject of origins. And we're going to be addressing those big questions of where everything came from. Those are the kind of questions that I was introduced to when I was a geology major back at UC Riverside way back in the day. I was introduced to the great world of rocks and fossils and the theory of evolution as to how we got all those things. I wasn't completely happy with all the answers that I was hearing, and actually I was led into a new area of religious faith. Today we're going to give you some evidence on the subject of where we even have a debate on where everything came from. Why is there such divergent views if the science should support a single view? Partway through this presentation there will be another video in which I'll be joining you, and also other people that are scientists and religious leaders who will be addressing the topic of the day. That will be our format as we go through our series. Right now we're going to turn things over to our local hosts, and again we want to thank you very deeply for joining us on this journey as we take a look at the great questions of where everything came from.
Well, welcome again. I'd like to once again welcome you to this 6-part series. This will be a series of 6 presentations on the controversial subject of origins. Where did everything that we see come from? We hope these topics will aid you in your personal understanding of origins, and while examining the nature of the ongoing debate, and this debate is actually often quite heated. The presentations will draw evidence from 2 models offered by science and by scripture. We will differentiate the models. We will explain their historical and cultural roots. And we'll also explain the basis which undergirds the thinking of each view. Tonight, we're going to be talking about the origin of the debate. How many of you have noticed the tension over the subject of origins and where everything came from? Well, I have. It seems that science and religion are somehow in battle or in combat over this issue. We don't think that it should be that way. But if we can understand where both sides are coming from to form their views, maybe we can understand a little bit better why those differences exist. The subject has even inspired bumper stickers. with symbols illustrating these conflicts, or the big conflict. There's been polls taken in the United States called the Gallup Poll, and most of you have heard of the Gallup Poll. The latest one in 2017 asked Americans, where do you think we came from? 3 opinions were given: recent creation, theistic evolution, and natural evolution. On the far right, you see on our screen, you have natural evolution, and then that is nature was sufficient in creating and organizing everything. Everything came from nature. In the middle is a view called theistic evolution, which means that God used evolution to create everything, and using evolution, he created all of these species that we see around us. And then eventually out of all that came you and me, human beings. And the diversity of life that we see today all came through an evolutionary process that was started by God, and it's taken millions of years for us to arrive at this point. The 2017 Gallup poll showed that 38% of Americans followed a recent creation. Again, we would call that a biblical view, that we have a fairly, by time standards, a fairly young earth, that the world, or at least life on it, is just a few thousand years old. Americans remain still to this day a fairly religious group, and America is still to this day a fairly religious country. And then in the middle, the theistic evolution number is pretty similar, and actually in this case the same as the recent creation number. That number is heavily influenced by those who take a position that, yes, we believe that God had something to do with evolution, but Darwin was right also. So this group includes people who have a high view of religion, but also have a high view of popular science. They try to make the two things work together, science and religion. And then finally, 19% of those who took this survey believed in natural evolution. And that is, God had nothing to do with it, everything evolved naturally, and that number is heavily influenced by today's young people who are brought up in an environment that favors this position. For the last century, that number was actually closer to 10%, but now there's a growing trend, particularly again among young people today, who feel that religion is the source of much of the problems and strife in the world. And of course, you look around, they have some evidence of that. Now, these numbers don't add up to 100% because some people don't state their opinion. However, we rarely see those kinds of people, but you can see that it's not exactly 100%. Some people don't state their opinions. Now, the word science comes from the Latin word scientia, which means knowledge. Science is defined as a system of acquiring knowledge based on what is called the scientific method, as well as the organized body of knowledge gained through such research. It's helpful to notice the two parts of this definition of science. First, there is hard science, and this kind of science you can do in a laboratory. It is testable knowledge, something that can be observed and something that can be predicted. Hard science sometimes is interpreted using current models and worldviews. But again, it's something that is repeatable. Sometimes you can see that when they do experiments, etc. Now, historical science is not testable knowledge. Historical science is something that can be observed or predicted. It's not testable knowledge, something that can be observed or predicted. You cannot observe it, you cannot predict it, because historical science is always trying to explain the past based on current processes and observations. But it's not repeatable, because it's looking back into the past and then it's trying to explain those things based on current observations. Not repeatable. For example, you can't repeat the Big Bang and look at it and tell exactly what happened there. So, historical science is always subject to favorite models and worldviews. In other words, historical science is always through the favorite models of the day and the worldviews of those who are interpreting the data. Now, let me give you an example of what historians can do with what we might call simple facts. Here's a history example. The Pilgrims that came to America in the 1600s, what were they seeking? Now, historians could write about this and say, oh, they were seeking land to take from the natives who were in North America. Or they could say they were seeking religious freedom and trying to escape from the intolerance of Europe. Or it could be something totally different, or all of the above. The historian's answer may tell you more about the historian than it tells you about the Pilgrims. Why? Because historians have worldviews that affect their interpretations. If, for example, facts are facts, why don't we all agree on everything if facts are facts? Believe it or not, this is very difficult. We don't all agree. We're not all Republicans. We're not all Democrats. We're not all religious. We're not all secular. We're not all highly educated in the sciences. We're not all theologians. We have different views. One of the things that we all need to remember is something that's very rarely understood or taught. There is data, and data would consist of hard numbers, and then there is the interpretation of that data. Now, that making sense of the data is what you're looking at. Data does not equal interpretation. When we look at data, data is just telling us what's there. It does not equal interpretation. There are two distinctly different things. Interpretation is always open for review. Hard science equals data. Historical is a story that's told based on the data that's received or perceived. The subject of worldviews is critical right here. So what is a worldview? Everybody, believe it or not, has one. It is the faith framework. We use that framework to interpret or make sense of our world. It's formulated by where and when we were born, by our parents, by our education, what kind and where we got that education. It is by our experience and our culture. All those things combine to give us a sense of meaning in the world that's around us. Now, 5 questions can help us examine and understand our worldview biases. First, what is your supreme authority? In other words, it's the place where we go to get help to understand something with a final answer. Who is the one that can give you the best authoritative understanding of what we're looking at? It could be science, it could be God, it could be many things for different people. The next one is, where did everything come from? And that's what Origins is, right? That's what we're going to be studying, these 6 presentations. Where did everything come from? And the next question is, what is your place in this world? What space do we occupy in this vast, unthinkably large universe? What role does our understanding of life play in answering this? And you see, our worldview will provide that information. So the next question is, what is your moral code? What is right and what is wrong? What are the great moral issues in the world today? Who are the good guys? Who are the bad guys? Depends on who you're talking to, right? This is the issue. What's the worldview? The good forces, the bad forces, and all that, the moral code that we have will identify them. And the last question is, what is your future? Where are you going to end up is a very key question. All of these things will contribute to the forming of your worldview. And this filter is what you will interpret the data through. Now, here's an example of how a worldview clearly interprets data. If you go to the John Day fossil beds, it's a national museum or monument, not a museum, a monument in Oregon. You'll see some marvelously preserved fossils there, mostly of mammal fossils. These fossil beds were first studied, written about, and promoted in the 1800s, greatly increasing the nation's understanding of life by Oregon's first state paleontologist, and he was a Christian minister. His name was Thomas Condon. And this is what he wrote about the fossil layers that he saw. He said, the hills from which these evidences were taken were made by the same God who made the hills of Judea, and the evidences are as authoritative. He added, the church has nothing to fear from uncovering the truth. He also said, evolution was simply God's method of working and therefore not atheistic or infidel. Obviously, he understood the biblical account of where everything came from and the story of the flood. Plus, he had a good understanding of the modern theory of evolution and interpretations or interpreting the fossils of his day. We could reasonably ask, what was Thomas Condon's supreme authority? This is the first question we ask under worldview. In other words, when science and the Bible conflict, what was the supreme authority? Even though he was a minister, his supreme authority was the popular science of his day. Our worldview helps us to interpret a lot of things. Our understanding of suffering, of wars, of where we came from. It will be helpful in your understanding of science and faith. Our worldview informs us of what we ultimately believe about the origins of the earth, perhaps even some of the intricacies of which came first. As we look and study some of these great questions, we'll see that what we believe about these questions, questions of pain and suffering in this world today, and these things are determined by the view, our worldview, that we have. Do you still have a place in your worldview for God? If so, what does he look like? How does your worldview help you come up with that picture? In 1998, a poll of members of the National Academy of Sciences, and this is a group of thought leaders and political leaders in science and education, they put together the curriculum that's studied in the schools and about how the public school teach about origins, where we came from, where everything, all matter came from, and so forth. So a poll was taken on their beliefs. It revealed their worldviews. Only 7% of these thought leaders and scientists believed in a personal God. They also asked about their disbelief in a personal God. 72% did not believe in a personal God. And 21% had doubts and didn't particularly want to make a statement. They were what we would call agnostics. They don't know. So a full 93% of these learned scientists, 93%, and these are thought-leading scientists, rejected God. It's logical to assume now that their worldviews would have influenced their approach to origins, and it would influence their interpretations of the data. But ironically, Western science had its roots in a different worldview. Now we're going back to the roots of the thing. As people, many years ago, they were motivated to study nature as the works of a creator God. The great early scientist Isaac Newton said this: "No sciences are better attested than the religion of the Bible." He saw no conflict between believing in a creator God and trying to understand and interpreting the things that we see in nature. When then did all of this change? Since the 1200s, universities in Europe, like Cambridge, that's on the screen there, they only taught that God created the world like the Bible said. And for centuries, all of the graduates tended to think the same as their professors did. However, in the last couple of 100 years, today's universities in the West only teach that nature, that is material, created and organized everything that we see. In other words, nature was deified and personalized in the storytelling of science. And now, most graduates, almost all of them, tend to think the same way as their professors. Science operates using models which are very difficult to change. they're meant to help us understand what we see. And a pioneer in the study of these changing models was a Harvard PhD physicist. His name was Thomas Kuhn. In the mid-1900s, he wanted to understand how the models change in science. For example, he wanted to see if he could somehow understand the way Aristotle, the Greek philosopher, saw things and viewed things and how he interpreted nature. He wanted to get into Aristotle's mind and see nature the same way that Aristotle saw it. It took a while, but eventually Kuhn felt that he had gotten there. But then he went to the next logical question. How do we get from Aristotle's place to here where we are now? There had to be some serious model changing along the way. How do you change large models like that? So Kuhn wrote this book, which became quite influential in the philosophy of science. He called the book The Structural Science of Scientific Revolutions. And he basically said that scientists operate using models, and they indeed are difficult to change. In fact, he came up with this concept called paradigm and paradigm shift. It's hard for scientists like anyone else to shift their paradigms and their models. It received a lot of criticism, especially from the science community, who like to think and project this idea that they are objective and the only facts that dictate their models and that their models are dictated only by facts and not the other way around, that the models don't dictate the facts. Yet, Dr. Kuhn caused enough rethinking about this that today there's general agreement that models are difficult to change. And the scientific community, as well as many in the world, can get stuck in that paradigm of viewing things through their models. So let's use as an example here a historical example from something called alchemy. Alchemy was a kind of predecessor to chemistry. For many centuries in the Middle Ages, a lot of the kings and rulers of in Europe had these people on their payroll, alchemists they called them, and they had a paid staff with budgets. And what they were trying to do was to tackle this challenge of changing lead into gold. Lead is heavy, gold is heavy. Lead is soft, gold is soft. Lead is bad, but gold is good. So for centuries, they tried to come up with a way in which they could change lead into gold, and yet they never could. The model endured. Here's another model example. Some people think that this is an electric light bulb on the screen, but perhaps it's not a light bulb. Perhaps it's a dark sucker. As soon as you turn on the switch in the room, electricity flows into the bulb, and the bulb sucks all the darkness out of the room. And therefore, the room then appears to be light. So darkness is sucked into this little bulb, and eventually the little bulb fills up with the dark, and no longer is anyone in the dark anymore. This one right here is full of dark. That's one way of looking at it. It's interesting how one can come from looking at things with a different model, and that sort of explain things well, but unfortunately it explains things wrong. Models on the subject of origins, that is, how nature operates are very critical, especially on the subject of whether or not there is a God involved. Notice this comment by Richard Lewontin. He's a Harvard biologist who says this: we have a prior commitment, a commitment to materialism. Moreover, that materialism, is absolute, for we cannot allow a divine foot in the door. Materialism, in this particular instance, is not talking about owning a Rolls Royce or a Mercedes Benz or any of the other things. Materialism in science or in the scientific world is the idea that material is all that there is. Material begets material. There's no supernatural forces seen, like a creator God involved in any of it. That's why he says we cannot allow a divine foot in the door, because they want to maintain their model. They are sticking with their model. Richard Dawkins, who is a famous atheist biologist at Oxford in England, says that biology is the study of complicated things that give the appearance of having been designed for a purpose. What? It's the study of complicated things that give the appearance of having been designed for a purpose. So scientists will agree that the things that we look at seem to suggest that they were designed. There is a complexity to it. They appear to be designed, but they prefer a random origin that includes a series of fortunate accidents to explain it. Francis Crick, a Nobel Prize winner, said this: biologists must constantly keep in mind that what they see was not designed, but rather evolved. So why do they have to keep that in mind if they're looking at the evidence to draw a conclusion? Sounds to me that the conclusion has already been drawn. They've committed to not letting a divine foot in the door. This worldview will absolutely affect the way that data is interpreted. But the human mind, well, it operates kind of like this. It looks at some objects, like this rock formation that you see on the screen. It understands that random forces could have created or shaped what we're looking at right there. It doesn't take very much imagination to expect that the wind and erosion and rain and all these other things will somehow randomly shape the appearance of this rock, depending on how hard it is and so on. We get that random forces are at work. But when we look at something like this, can random forces create that? It becomes a bit more complicated when we see design and structure. When we talk about the subject of origins, it's hard to miss the great and most fundamental of all science questions, and that is, how did life appear? And when you talk about life, there's a wide variety of understanding of what life even is. So here's a definition from Webster's. Life is a principle of force that is considered to underlie the distinct quality of animal beings characterized by a capacity for metabolism, growth, reaction to stimuli, and reproduction. How does that hit you? Does that adequately describe what life is? This definition is a little bit underwhelming when a mother or a father holds a newborn child in their arms. There's certainly no consensus regarding the definition of life. There are many different forms of life, not just different animals, plants, and fungus, and bacteria. Perhaps if life did appear, it could have appeared multiple times in forming multiple things. And one of the most obvious big questions is, how did life arise from inorganic matter? Now, the answer to that question, it remains a great unknown. No one, even in the scientific community, can give a definitive answer to that question. Did life come from outer space? Did something from outer space come to this earth? And there are people who believe that billions of years ago, something happened here on planet Earth that transported life here. And some feel that billions of years is just randomly happening things, is not enough for life to be created. Maybe it came from these little green men flying a flying saucer. Some of the scientists in the world actually believe that something like this could have occurred. Or maybe life appeared via a meteorite striking the planet. Maybe a planet way out there in the universe exploded somewhere and had little pieces of life on it, and pieces of that planet went through our atmosphere, crash landed on the earth, and seeded life here. Then life evolved, and eventually you and me, we're the result of all that. That's one view. Louis Pasteur, the famous French biologist, he tackled the subject of where life came from, dealing with a theory in his day that was known as a spontaneous generation, that life simply appeared from time to time in different places, and he conducted a series of experiments, and he came to this conclusion. There is no known circumstance in which it can be confirmed that microscopic beings came into the world without germs, without parents, similar to themselves. This disproved the popular theory of spontaneous generation. Now that led to the framing of the biological law of biogenesis. Remember, because if biogenesis is the whole idea that living things only come from other living things. Bio beginnings. You can't get an animate thing from an inanimate thing. However, today, modern scientists generally believe something different. Nearly all scientists believe in abiogenesis. That is, life came about via natural chemical processes from a hot chemical vent or pool, and they would disagree with Pasteur's law. And the law is something provable, whereas they're talking about historical science. Remember the difference between hard science and historical science? They are trying to imagine how something that took place in the past happened without no proof today that that is in fact what happened. They actually tried to mimic it. And remember, because if biogenesis happened, it was because of chemistry. Long before there was any biology involved, it had to have been because of some chemical process. There was this attempt to imagine how life could have formed from chemistry. The Stanley Miller-Urey experiments of the 1950s and 1952, it was an attempt to recreate an environment of what they imagined Earth's early atmosphere was like. It involved gases, common chemicals, water. They used electricity to simulate lightning. And it did create some simple amino acids. And for a while, this was put out there as, see, this could have been some sort of primordial soup where life sprung from. Primordial soup where life sprung from. However, since that time, this model has fallen way, way, way out of favor. Original conditions are now thought to be quite different, including the early atmosphere. But how did the basic chemicals present on Earth spontaneously arrange themselves into something resembling life? And then this big question, how did we get DNA? Everything that has life of some sort is DNA. Where and what did the first cells look like? More than half a century after the chemist Stanley Miller projected his primordial soup theory, we still can't agree about what happened. Perhaps primordial soup that had bubbles in it, and this is the next thought, and those bubbles that you see in it are the beginning of little cells. Now, cells are very interesting things. Cells weren't really seen or identified until around 1665 by Robert Hooke. And he used a rather rudimentary microscope that he had set up. And when he looked at them, it was the first time, by the way, that anyone had ever seen cells. They reminded him of rooms at a monastery, which were called cells, and by the way, that's where we get the name cells from. By Darwin's day, it was thought they contained mostly protoplasm, which is this jelly-like substance. Basically, then, life consisted of rooms with jelly in it. Well, things are quite different now. As biologist Michael Behe, he's pointed this out. Now is the turn of the fundamental science of life, modern biochemistry, to disturb. And what are they going to disturb? The simplicity that was once expected to be the foundation of life has proven to be phantom. Instead, systems of horrendous, irreducible complexity inhabit the cell. Now, we could spend a lot of time discussing the incredible complexity there is in one single human cell. I've heard it said that there is more activity in one single human cell than New York City during rush hour. Incredible. So, there are 40 trillion cells in our bodies with 200 different types and functions. Now we're talking about big time complexity here. If there's a pothole that science usually runs into, and it almost never misses this pothole, from Darwin all the way back, it always assumes that things are simpler than they are. This makes sense from an evolutionary standpoint because the simpler things are, why, the easier they would be to explain as arriving from some random force. However, we do not see a lot of simplicity, particularly when it comes to life and life forms. We see, however, a lot of complexity. Remember the first model of alchemy where they tried to change lead into gold? They thought that it would be a simple process. There were so many similarities, but their assumptions were wrong. There is, in fact, great complexity between even what people think are simple elements like gold and lead. And the idea of changing one element into another element is exceedingly difficult and in most cases impossible. Now, going back to the day of Darwin, there arose with his theory of survival of the fittest and the origin of the species, there arose what could be considered the perfect storm for evolution in the mid-19th century. And there were some factors that contributed to it. First, there was the weakening of the Bible's standing. The Bible had been taken apart for the past few years in the 18th century and the beginning of the 19th century from something called higher criticism. Some scholars did much studying of the Bible, and they tried to imagine different authors and different sources from where the Bible was taken from. They ended up with a picture of the Bible that was kind of stuck together by a number of ancient writers and editors. It was not authoritative or inspired by any God, but simply a very interesting book that also affected religious training, as Darwin in Cambridge was also taught a similarly low view of the Bible. So the Bible had been reduced from this is the Word of God, that this is just some writings of a group of religious individuals stuck together as a book. A second factor was the discovery of key fossils, all the dinosaurs. And then a third factor was that there was ignorance about the complexity of genetics. Life seemed simple, with cells and jelly protoplasm. Genetics was not understood very well, in most cases, not at all. Changing simple things into other simple things seemed very easy to Darwin. And finally, there was this growing belief that the world was perhaps millions of years old. Now, this idea was coming from geologists like Charles Lyell, who was beginning to imagine that the world was 1 or 2 million years old. And what this gave the evolutionists was plenty of time, because in order for evolution to be effective, at least effective as a theory, you have to have lots of time so that all these changes that were assumed to be happening naturally could take place. Charles Darwin's contribution to the field of origins was in proposing a mechanism that seemed to be workable. Evolution was already well accepted by many in his day, but when he came up with something that helped the theory along. He graduated from Cambridge University, and he was, of all things in his studies, a religion major. And he signed up to be a naturalist on the HMS Beagle, which was a ship that was on a cruise to map the world. On this cruise, as the naturalist on board, he was able to make a number of observations from his study of nature along the way. When he got to the Galapagos Islands, he noticed some very interesting things. Some of his observations would eventually become a manuscript that would be published in 1859 in his book called The Origins of Species. So, what did he see? He went to the Galapagos Islands, pictured here on the screen, and the Beagle crew, because they had to get food from wherever they were buying these tortoises to eat. The tortoises that they were presented with had different shaped shells. The locals told them that the shape of the shells identified the islands that the tortoises came from. Now that got Darwin to thinking that surely they had a common ancestor, and when they're on these different islands, after a long period of time, their shells changed a little bit in a shape that were unique to that island. He also collected some birds, and he took those birds back to England. And not feeling that he was an expert on birds, because he wasn't, he took them to some of his friends, and they told him these birds are finches. And he said, how can they all be finches? Because they don't look alike. They have different bills. But they were all finches. The larger billed finches were able to crunch larger, harder seeds in their food supply than the ones who had the smaller bills. So he imagined that they all, since they were all finches, had a common ancestor, and all of these finches changed to help them survive in their particular habitats. All of this led him to come up with his theory, the survival of the fittest. What he saw was a natural process by which organisms best adjusted to environments are most successful in surviving and reproducing. And from that observation, he proposed a net evolution, which is a larger scale permanent change that results in the formation of higher taxonomic groups. If you have enough time, he's saying, little changes will add up to big changes. In other words, critters become different critters over time depending on the environment in which they're in. And what he's saying here is that nature was selecting the parents. And where Darwin grew up in England, well, they did a lot of breeding of animals, and to get the certain characteristics. They bred dogs, chickens, pigeons, everything, to get the characteristics in these animals that they were looking for. That was man selecting. That was not natural selection, that was unnatural selection. How did nature select animals? He assumed that nature was selecting the fittest animals, the strongest animals. This was Darwin's world-changing book on the origin of species by means of natural selection or the preservation of favored races in the struggle for life. What Darwin contributed was a theory that explained how evolution worked. This was a necessary thing for the time that he existed in, because there were many different theories out there. Maybe giraffes reaching for the tall trees over the years would make their necks longer. Since the survival of the fittest, however, doesn't change the genetic code of the living things, all it does is make the species fit. A new theory has emerged that does change the genetic code by mutations, and this is sometimes called geo-Darwinism. However, there are even more problems with this neo-Darwinism. So, Dennis Noble, he said this, and Dennis Noble, by the way, he's a physiologist in evolution from Oxford. A lot of these people seem to have come out of Oxford University there in England. He said, all the central assumptions, the modern synthesis, often called neo, I think I said geo at one point, neo-Darwinism, have been disproved. In other words, they have disproved everything that you can do in the laboratory to test for how mutations can change genes into something that's more complex and better and evolving forward. You're just getting broken animals when you have mutations. At this point, biology is in trouble, and they've tried to explain this. Stephen Meyer, he said, the technical literature in biology is now replete with world-class biologists routinely expressing doubts about various aspects of neo-Darwinian theory. Rarely has there been such a great disparity between the popular perceptions of a theory and its actual standings in the relevant peer-reviewed science literature. So this idea that Darwinian or neo-Darwinian theory is well accepted and understood in the science world, this is not so. They are back to the drawing board as to what makes evolution work. There's no doubt that it did happen, thinks most scientists today. They just don't know how. So let's hear something here from experts who will explain why this debate on origins and where the differences came from. Pay attention to this video.
Bereshit bara Elohim hashamayim v'haaretz. In the beginning, God created the heavens and the earth. And pretty much for centuries, through the Middle Ages, that was a single thought that people had about where origins came from. But then toward the 1800s, the age of reason that it is called now by science, the thought that maybe there was not an active God out there, and maybe the laws of nature was all that was in operation. So this skepticism grew about the biblical account. Charles Darwin was taught in a university, Cambridge University, that had this skepticism. And pretty soon, the worldview about where we came from dramatically changed. Today, we still have this debate going between creationists and evolutionists. And let's now take a look at the origin of this great debate.
To understand this, we need to go back to where science came from. It was a revolutionary new way of understanding our world. And what it did was it said, we're not going to bring all of our preconceptions into this. We're not going to let philosophers like Aristotle or somebody else tell us how the world works. What we're going to do is we're going to actually look at the world. We're going to use our empirical senses. That's our eyes, ears, sense of touch, those sorts of things. And those data that we collect using those senses, we will interpret in a logical way. And that was a very powerful tool then for figuring out what's going on in the world. But then some people added an additional rule called methodological naturalism. It said not just that we should logically interpret data and that data will drive our theories. It said those theories may not ever come to the conclusion that God was involved in any way. It can only be naturalistic explanations that we can come up with.
The idea of natural selection actually was kind of around in those days when Darwin was developing his theory. Other people, in fact, had proposed essentially the same thing, but nobody had developed it in detail and with lined up arguments and evidence and made a case for it. So Darwin collected these ideas, and he credits reading Malthus on population over population and the competition for resources, and he was thinking about nature as a kind of a competition between different organisms, and then he realized there's more organisms than there are resources, so naturally those who are stronger would get the resources and survive. And he played off that actually an inevitable conclusion. It's self-evident that if you have limited resources, the stronger are going to succeed better than the weaker. But Darwin's real strength, I think, was in developing a series of arguments that rested on evidence that, in fact, this kind of thing does happen in nature.
Well, I would say Darwin is certainly an icon in science. He's respected, and his contribution is perceived as really world-changing in some respects. So he is one of the holy saints of science, you know, at the same level as Newton or other very important figure, Galileo Galilei. Now, when it comes to the mechanisms that Darwin suggested in terms of what could bring change in species or what could originate new species, when you begin to look at the granular level of the theory that he proposed, that might not be as popular nowadays. Why? Because we have so much more understanding of the complexity of life and understanding of basic things like the DNA, for example, that was not common knowledge at the time of Darwin. So he could envisage a much simpler way, in a sense, or a broad sketch of what he thought could happen, but he didn't have a clue of what was actually happening inside cells.
Today, Darwin's views are somewhat under scrutiny, but it would be helpful, I think, to kind of dissect apart his views. One of his views was naturalism, and that view is under challenge. There is evidence, maybe there's gaps in nature, that there must be some kind of power involved. And of course, the intelligent design movement has used that and developed that argument that in fact there is something more than just nature. Another view of Darwin is that natural selection can account for varieties that adapt to local habitats. And I think virtually everybody accepts that. Then Darwin's view that microevolution, if you want to call it that, this natural selection of small changes, that accumulates over time to eventually produce macroevolution. Well, scientists have held to that very strongly because they were afraid to give creationists any kind of a foothold. But as time has gone on, the scientific community has kind of gotten wary of that argument, saying, no, we don't see this is going to work. For example, if it's advantageous to have a longer tail, well, you can get that tail longer and longer and longer, but you're never going to make a wing out of it. How do you get a new organ? Microevolution just is not going to add up to a new organ. Plus, looking at the fossil record, you do not see that in any way. Looking at modern experiments, you do not see that in any way. It just doesn't work. So at the present time, the scientific community, the evolutionary biology community, is looking for ways to explain macroevolution. So far, they haven't found one, but there's many, many, many of them that recognize that Darwin's theory doesn't cut it. Another aspect of Darwin's theory is common ancestry. And I think for the most part, common ancestry is still accepted without empirical evidence, I would say, but as a necessary conclusion from materialism. If you're going to have only natural processes, you're not going to have different kinds of animals popping into existence all over the place. You're lucky to have it once. And so if you have once, then maybe you can play with it from then on. But common ancestry is one I think is weakly supported, but it's necessary for naturalism.
The people who are molecular biologists and who are experts in the field of how genes act and how they function and whether or not genes get duplicated and what bacteria do with extra DNA if they encounter it, those guys are often working on particular problems. They're trying to solve cancer. They're trying to come up with a way of dealing with COVID. They're trying to solve a particular problem. And then you have another group of people over here who are trying to show that evolution is true. And they'll hypothesize about things that happen with DNA, these massive gene duplications that then resulted in new functions. But they never actually check their hypotheses with the people who actually know what they're talking about in terms of molecular biology. So there's often not a whole lot of crossover in between those fields, the theoretical evolutionary biologists and then the ones who actually are where the rubber meets the road. So I think sometimes hypotheses get generated about how these processes could have taken place. They're not necessarily in line with what even evolutionary molecular biologists would have to say. So there's sometimes a disconnect there. So that's the main way. They just ignore it often. The people who are working in problem-solving areas, well, evolution obviously took place. Have you thought about it? No, I'm busy trying to solve cancer. These guys down here, evolution obviously took place. Well, have you thought about it? Yes, I'm thinking about it very carefully. I think that this happened and this happened. Well, but that can't happen. Well, don't dissuade me with facts, ma'am. So sometimes there's a lot of what are called in the literature just so stories, that this must have happened this way. Do we have any proof? I mean, maybe, but there's no it happened in the laboratory.
Worldview are kind of like glasses. That's one of my favorite illustrations. But the glasses, everyone has a pair. Some people aren't as aware of their worldview as others, but basically it's the lenses through which we interpret life. Worldviews are really helpful in what we would use them to answer the big questions. Does God exist? Does he or doesn't he? However you answer that question determines a whole lot of direction of where you're going to go. Where did the world come from? What does it mean to be human? Is there life after death? Ethics. Why are some things right or wrong? And then maybe another question might be, is there a grand overarching story that gives meaning to existence or not?
So what we think on the subject of origins is entirely shaped by our worldview. And does your worldview include a picture of a large and powerful and caring and capable God? Is he able to give us a record of what's taken place at the beginning? Does he care enough to think we actually would like to have that record? All of these things affect how we view the data, how we interpret the data through the filter of our worldview. Let's begin to take a look a little bit more now about some of the positive images that Scripture holds about the God who created us.
Now let's just shift a little in our thinking and do a little bit more scriptural view of the subjects. It's interesting that materialism says that everything is made out of material and only visible forces are involved. That's against the Bible's view that says there's other forces out there. The Bible says in Hebrews 11:3, by faith we understand that the universe was formed at God's command, so that what is seen was not made out of what was visible. Here we have a view that's definitely not materialism. There's another force out there, and we call that force God. I'd like to share with you a story that has to do with the Apostle Paul, the famous Apostle Paul, and his encounter with early science philosophers. These were people that he met at Athens in ancient Greece, and there were many people who think that that's where Western science got its beginnings, because there were so many philosophers and people who were thinkers in that area. Some foundations were laid through the philosophers' questioning of the old stories about how the gods had made everything. They began to observe things and just think a lot and talk a lot about what they were thinking a lot about. The Apostle Paul came to Athens on one of his journeys, and he was alone. And he was waiting for his companions to catch up with him, and he met some people in the marketplace, and he started a conversation with them, and it went something like this. And we find this written in the book of Acts, chapter 17. Now, while Paul waited for them, his friends in Athens, his spirit was provoked within him when he saw the city was given over to idols. Lots of gods, and there were lots of temples there. Then certain Epicureans and Stoic philosophers encountered him, and some said, "What does this babbler want to say?" Now, Epicurean philosophers followed a great thinker called Epicurus, who said that the gods are not involved in the world. They are too busy having fun. Mankind should, don't worry, be happy. There is no afterlife, according to Epicurus. Well, that philosophy, even though it's ancient, we can see the evidences of its existence even today. The Stoic philosophers followed Zeno, another great mind in the ancient Greek past. And this is what he said, something a bit different. God is in nature, not above it. Man's happiness comes from overcoming wrong attitudes through increased knowledge. There is no afterlife. In other words, study, 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 and grow your brain. That's the way to live. There is no afterlife. So the one area where Zeno and Epicurus agreed was that there was no life after death. But Paul came along talking about such a thing. He said there was. Others said about Paul, he seems to be a proclaimer of foreign gods because he preached to them Jesus and the resurrection. He talked about life after death, which these science-oriented people doubted. They took him and brought him to the Areopagus. And this is this hillside pictured on the right there on the screen. And they said, "May we know what this new doctrine is which you speak." So Paul was a very educated man, and so he stood in the midst of the Areopagus and said, "Men of Athens, I perceive that in all things you're very religious. For as I was passing through and considering the objects of your worship, I even found an altar with this inscription, 'To the unknown God.'" To the unknown God. "Therefore, the one whom you worship without knowing," he says, "him I'm going to proclaim to you." So what's he saying? He's saying that you even admit that you don't know everything that's up there. There may be other gods. So let me tell you about a God that's up there. Then he goes on to tell them that God, who made the world and everything in it, since he is the Lord of heaven and earth, does not dwell in temples made with hands, nor is he worshipped with men's hands as though he needed anything, since he gives to all life, breath, all things. We ought not to think that the divine nature is like gold or silver or stone, something shaped by art and man's devising. Truly, he says, these times of ignorance God overlooked, but now commands all men everywhere to repent, because he has appointed a day on which he will judge the world in righteousness by the man whom he has ordained. And he has given assurance of this to all by raising him from the dead. And when they heard of the resurrection of the dead, their response was almost predictable. Some of them mocked because of their worldview. He's shaking their worldview. These are science-oriented people. They couldn't even imagine anything like that. That's a miracle which is working against the laws of nature. And some mocked at that. After all, a being that made heaven and earth, a creator who gives and actively maintains the life of all creatures, that he's involved in our lives day to day, someone who can't be contained in temples nor properly represented by man's reason or art. In other words, any graven image that we can think of, any concept in which we can try to put God in this box, is going to be insufficient. He's far greater, far above anything that we can conceive, because he is God. He made everything. He's a divinity above natural laws and fully capable of suspending them at will. That even means raising people from the dead if he so chooses. He's a God to whom we are responsible. And they went through what they call, or what we call, a paradigm shift, because however some believed. And it was for them a change in their perception of things. Their worldview changed, and they now had a better explanation of everything that they saw around them, and that is that it's created by a creator God. Alistair McGrath, he wrote about Richard Dawkins, his colleague at Oxford University, and his atheism. Alistair shares his own story where he says, although I was passionately and totally persuaded of the truth and relevance of atheism as a young man, I subsequently found myself persuaded that Christianity was a much more interesting and intellectually exciting worldview than atheism. Can one be a creationist and do good science? We've read a number of statements doubting that possibility. But this is Wernher von Braun. He at one time was the head scientist at NASA. And he said, and by the way, if there's a single person most responsible for putting a man on the moon, it's Dr. von Braun. Now, this is what he said. Religion and science are sisters. The one seeks knowledge of creation and the other of the Creator. So yes, friends, we can do good science. You and I can bring science and religion together and still get the work done. It's not either or, it rather is both and. And this is a very different and complex, even perplexing story. It might mean in the minds of many a paradigm shift, but it's possible. And for many of us who've been led, we've been led to do just that. And you know what? It all makes sense. We are so pleased that you're here tonight. This is only session 1 of Origins, and we will continue tomorrow night at 7 o'clock with session 2. And let me look at my schedule. And tomorrow is the origin of humankind. Where'd you come from? Come tomorrow, we're going to tell you. Thank you for being here with us tonight. God bless you, and we look forward to seeing you tomorrow night, same time at 7 o'clock. Have a good evening.